Hi students, today we're taking a look at lesson 9.3, which is equivalent ratios, and that is on page 439. So make sure your book is open to page 439 and we will get started. Today's video, I'm going to give a shout out to Bryce because he somehow figured out a way to subscribe to my YouTube channel despite the fact that I thought I had that turned off. And I'll shout out to Callie because she told me she really enjoyed hearing the shout outs yesterday. So today's lesson is all about equivalent ratios. Now we talked yesterday that ratios and fractions are two different things because fractions compare parts to wholes and ratios compare parts to parts, but they both can be written in fraction form. And if you can find equivalent fractions, finding equivalent ratios is going to be very easy for you because mathematically they work the same way. So today's solve and share lesson says Sally used all of the paints shown below to make a certain tint of orange paint. How many pints of red paint should be mixed with 24 pints of yellow paint to make the same tint of orange? Solve this problem any way you choose. So she's got some red paint, she's mixing it with yellow to kind of get an orange color. And this shows a ratio of 3 pints of yellow to 4 pints of red. So now they're saying they want to have 24 pints of yellow paint. So one thing I could do is I could just copy this picture over and over again, keeping the ratio the same until I have 24 pints of yellow paint. It would look something like this. Now, that is a lot of paint cans. And if you had to draw this picture, it would take you a long time to redo this picture. It took me 8 times to redo it to get to where I would have 24 yellow paint cans. So let's look at a different strategy. Because I could draw this and I could go through and I could count up all of my red paint cans. But if I'm in a time crunch, that's going to take a lot of time. So let's consider a different way. Now, yesterday when we looked, we said we could do a tape diagram. So that was where we drew our rectangles to match our, whoa, that's a really big rectangle. We could draw our rectangles and label them. So I could draw a tape diagram and have 3 boxes on the top to represent the yellow paint and 4 boxes on the bottom. So 1, 2, 3, 4. And if I've got 24 pints of paint, 24 divided by 3 would be 8. So I would know that there would need to be 8 in each box to keep that ratio equivalent. And if there's 8 in my top boxes, there would have to be 8 in my bottom boxes. So I could say, okay, if there's 8, 16, 24 things of yellow paint, then I would have 32 of the red paint. So that would be one way you could do this. The second way that we are going to see today that we can solve these if we didn't want to do the tape diagram would be to make a ratio table or to set it up as a fraction and find an equivalent fraction. Because if you remember when you did fractions, which I know it's been, we haven't worked on fractions for a few weeks now, but when we did, we talked about what makes fractions equivalent. And one thing that makes them equivalent is when the top and the bottom are multiplied by the same numbers. So the way I get from 3 to 24 is I multiply by 8. The way I get from 4 to 32 is by multiplying by 8. And we know that any fraction over itself is just equal to 1, because if I had a pizza that had 8 parts and I have all 8 parts, I have one whole pizza. And we know that when we multiply any number by 1, it stays the same. So what I am essentially doing here is I'm doing 3/4 times 8/8, and that gives me 24 32s. So now it says using the same ratio of yellow paint to red paint, how many pints of yellow paint should be mixed with 16 pints of red paint? So again, I could set up an equivalent ratio, or I could do my tape diagram. I'm going to do a tape diagram just because I know we're still getting used to using those. Okay, so I don't remember where I was because Miss Brown just came to my door and interrupted me. So, um, we were, I believe, looking at the look back problem, and it says we have 16 pints of red paint. So I'm setting this up as a tape diagram. If the top is my yellow paint and the bottom is my red paint, and I have 16 pints. I have 4 boxes. So 16 divided by 4 would be 4. So I'm going to put 4 in each box, and we said whatever we put in our um, top or bottom boxes, it's going to be the same in the opposite. So if I have 4s in my bottom boxes, I'm going to put 4s in my top boxes. So 4, 8, 12. I'm going to need 12 pints of the yellow paint. So if you need to pause the video to get this written down, do so now. I'm going to go ahead and move on to the next page. So this page is always the essential question and gives us an example of how we can work these out. So today's question is, how can we find equivalent ratios? So they say for every 16 basketball players in Crystal County schools, there are 48 baseball players. If there are 64 basketball players, how many baseball players are there? So they say you can use the structure in a ratio table to find equivalent ratios. So you guys are used to input-output tables, which is where you have a number here and you do something to the top number to get the bottom number. These are ratio tables. So the number of basketball players is related and the number of baseball players is related. But because these are two different quantities and they're representing two different amounts, I'm not going to do something to the 16 to turn it into 48. I'm going to be going from 16 over. So I'm kind of seeing, what do I do to 16 to turn it into 32? So the way I get from 16 to 32 is I'm multiplying it by 2. I'm doubling it. If I double the number of basketball players, I've also got to double the number of baseball players. So 48 times 2 would be 96. So on each one of these, they start with the original ratio and they multiply it by a number. Whatever they multiply the basketball players by, they're going to multiply the baseball players by the same thing. So if we're trying to figure out 64 basketball players, what they did was they just kept increasing it by 1. So they multiplied by 2, multiplied by 3, multiplied by 4, and they got to 64. So then they know, okay, we've got to do 48 times 4 to figure out how many baseball players we would have. So we would have 192. The other way that they say you can do this is kind of like what I was showing you guys on the other page, and that was you can set it up as an equivalent fraction problem. So we could say, okay, what do I have to do to 16 to turn it into 64? I've got to multiply it by 4. Whatever we multiply a fraction by on the top, we've got to multiply it by the same number on the bottom to keep it equal. Because this, like we said, is like multiplying by 1. Because 4 over 4 would be equal to 1. So 48 times 4 would be 192. And they say that 16 over 48 is an equivalent ratio to 16 over 192. So they say, if you extend the table above, how would you find the next ratio of basketball players to baseball players? So if we extended this, what would we have to do to 16 to fill in the next spot? We would have to multiply it by 5. And whatever we multiply by on the top, we're going to multiply by the same number on the bottom. So with some video magic, there is what we would do. We would multiply the 16 by 5. That would give me 80 in my top part of my table, and I would multiply 48 by 5, and that would give me 240. So if you need to pause the video to fill that in, go ahead and pause it now. On the next page, gives us another example. On this example, they're just explaining that not only can we multiply to go forward in our table, the reverse is true as well, or the inverse. We could divide by the same number on both the top and the bottom to find a smaller ratio. So I can multiply both the top and the bottom by 2. I can multiply by 3, divide by 3. So they just show you an example of that. So on the guided practice, it says, what are 2 ways you can find an equivalent ratio for 12/16? So if we're looking at this way they were just showing us, we could divide both the top and the bottom number by a common factor, or we can multiply each term by the same multiple. So I'll take a second to type that. So if you need to pause it to write that in, or if you want to give a different explanation, that is fine as well. On 2 through 4, it says write an equivalent ratio for each of the given ratios. So I'm going to do the first one, and I'm going to let you guys do 3 and 4 on your own. So if I have 12 21s, I can either multiply both the top and the bottom by the same number, or I can divide. So I know that 12 and 21 share a common factor of 3, because we just did common factors and multiples and stuff like that in the chapter before this, and that's part of the reason why they had us do that, because that will help us when we're working with these ratios. So because I know that these share a common factor of 3, I'm going to divide both the top and the bottom by 3. So 12 divided by 3 would be 4, and 21 divided by 3 would be 7. So an equivalent ratio for, oops, that's really teeny tiny, for 12 21s would be 4 7. So I want you guys to try 3 and 4 on your own. On 5 through 8, it wants us to write 3 ratios that are equivalent. So I will do a couple of examples and I'll leave a couple for you guys to do. So I'll work with the 8/14 since that's one of the bigger ones here. So I know these both share a common factor of 2. So I'm going to divide both 8 and 14 by 2. So 8 divided by 2 would be 4, and 14 divided by 2 would be 7. So one equivalent ratio would be 4/7. I could also multiply these by a common factor, or a common multiple. So I'm going to make it easy on myself and multiply both of these by 2. So 8 times 2 would be 16. 14 times 2 would be 28. And then it tells me I have to have 3. So I could do 8 times 3, which would be 24. And I could do 14 times 3, which would be 42. So that gives me 3 for that one. Because this one is kind of upside down, I know it looks like an improper fraction, but we've got to remember that these aren't technically fractions, these are ratios. So again, I could look to see, is there a common factor? 9 and 5 don't share any common factors, which means I'm going to have to multiply these to make them bigger. So I'm going to multiply by 2, so I would have 18 over 10. Maybe I'll just slide that up next to it. I'll put a line in between for my fraction. So I could have 18 tenths. I can multiply both of these by 3. So 9 times 3 is 27. 9 times 5 is 15. So that would be an equivalent ratio. And then I need one more. I'm going to multiply both of them by 10 because it doesn't say that I have to go in order as far as like 2, 3, 4. So I know that multiplying things by 10 is really easy, so I'm going to make it 90/50ths. So I'm going to leave 5 and 8 for you guys to try on your own. Okay, on the back, we have this table, and this is a problem you will see on your study island. And it says equivalent ratios can be found by extending pairs of rows or columns in a multiplication table. Write 3 ratios equivalent to 2/5. So what they're saying is that 2 over 5 is a ratio. If I look at the next set of numbers in there, they're going to be equivalent ratios too. So the next number would be 4 and 10. So I could have 4 over 10. I could have 6 over, what's the next one in this one? 15. Or I could have, I could skip to the end and I could say, okay, I've got 12 over 30. So those would be 3 equivalent ratios for that. So I'm going to leave, let's see. You guys do not have to do the higher ordered thinking, so you can cross that one out. And we talked about this one yesterday in class, so you don't have to worry about number 12. So I want you guys to try 10, 11, 14, and 15 on your own. And I will see you tomorrow in class. Bye.